Hello, fantastic viewers, welcome to my channel. I'm CySyst. I am a programmer and cybersecurity analyst. I have so many secrets and technique in cybersecurity, IT, technology, and the latest news that I'm thrilled to share these with you. Don't miss out on this opportunity and subscribe to my channel now. I create new videos nearly every day. Hit the subscribe button, ring the bell, and give that thumbs up. Today, I'm excited to guide you through Python programming. This course is an introduction to programming. Using the Python programming language, you will learn how to read and write code, as well as how to test and debug it. This course is taught and it's designed for students with or without prior programming experience. If you'd like to learn Python, let's start. The process of acquiring a new programming language shares resemblances with learning a new spoken language. Just as human languages employ words to construct sentences, programming involves assembling lines of code to convey instructions. These lines of code serve as a means to interact with computers, akin to sentences that direct them in performing tasks. In this segment, we will embark on acquiring the language essential for computer interaction as we delve into fundamental aspects of Python. Our journey commences by acquainting ourselves with the fundamentals of programming, initially understanding the rationale behind the utilization of Python by security analysts. Subsequently, we will establish the groundwork for Python proficiency, starting with an exploration of data types. We will then delve into the concept of variables. Lastly, we will familiarize ourselves with distinct directives that Python offers, such as conditional statements. These statements introduce logic into our programs, aiding in decision-making. Another category of instruction we will grasp is the iterative statement, which empowers us to repeat a specific code segment multiple times, eliminating the need for redundant rewriting. My engagement with learning Python yielded professional benefits by affording me the ability to liberate time from repetitive tasks. This liberated time is redirected towards tackling more intricate challenges and predicaments. Successful integration of automation curtails my overall workload, amplifies productivity, and diminishes the prospect of human errors. The deployment of automation further enables me to concentrate on my engineering responsibilities, characterized by attributes such as inventiveness, collaboration, and inventive troubleshooting. Are you prepared to embark on your Python programming journey? Let us initiate this endeavor. Security professionals utilize a range of tools, and one such tool is computer programming. Programming involves crafting a specific set of instructions for a computer to execute tasks. To illustrate, consider a vending machine, which can be likened to a computer providing food or drinks to customers. In this scenario, a customer inserts money into the machine and selects an item. If the customer gives the machine $5 and chooses a $2 candy bar, the machine processes this instruction and dispenses the candy bar for $2 while returning $3 as change. Numerous programming languages exist, but our focus here is on Python. Python is categorized as a general-purpose language, capable of creating a diverse range of programs. It is not specialized in any particular field but finds applications in areas such as web development and artificial intelligence. Python is commonly employed for website building and data analysis. In the realm of security, Python is employed primarily for task automation. Automation involves leveraging technology to reduce the need for manual effort in performing routine tasks. Python excels at automating concise and uncomplicated tasks. For instance, a security analyst grappling with a security incident might possess a log containing crucial information. Python can efficiently sift through this data, enabling analysts to quickly locate pertinent details. Similarly, Python can manage access control lists, ensuring consistent access management even when employees depart the company. Beyond automating individual tasks, Python can unify separate tasks into a streamlined workflow. For example, if a playbook dictates that an analyst must resolve a specific situation, by delivering a file and notifying the relevant parties, Python can seamlessly connect these steps. The question arises, why do security professionals opt for Python in these contexts? Python boasts several programming language advantages. Firstly, its user-friendly nature, resembling human language, requires less code, and is highly readable. Python programmers also benefit from adhering to standard guidelines that enhance code design and readability. Additionally, Python enjoys robust online support and offers an extensive repository of built-in code modules for diverse tasks. These factors contribute to Python's continued demand across various global industries, making it a staple in security careers. So, with these compelling advantages in mind, let's take a brief pause. In the next segment, we'll finally embark on running some Python code. Now, let's install Python. First, navigate to python.org to download the latest Python version for installation on Windows. Click on the Download tab. Over here, there are multiple options for various operating systems. Opt for the Windows operating system and proceed by clicking on it. Next, execute the installer. Before selecting Install Now, ensure to mark the checkbox labeled Add Python to Path. Afterward, proceed with the Python installation, patiently waiting for it to conclude. An IDE Integrated Development Environment is a software application that provides tools and features to streamline the process of writing, testing, and debugging code. We use IDEs to make programming more efficient and productive. In this tutorial, we will use Jupyter Notebook, which is one of the various integrated development environments. Jupyter Notebook is an open-source web application that allows you to create and share documents containing live code, equations, visualizations, and explanatory text. It's widely used for data analysis, machine learning, scientific research, and more. To install Jupyter Notebook using pip, open your terminal or command prompt and type the following command: pip install Jupyter. After installation, you can start Jupyter Notebook by typing the following command in the terminal: Jupyter Notebook. This will launch the Jupyter Notebook interface in your default web browser. Once Jupyter Notebook is running, you can create a new project by clicking on the New button on the top right corner of the interface and selecting Notebook from the drop-down list. Now, you can change the name of the project by click on Entitled and, for instance, call it Project 1. Click on Rename. In the newly created notebook cell, you can write your code. Let's now engage in practicing the composition and execution of code. In the context of Python, our written work is referred to as a script or a program. These terms have nuanced distinctions between them. To draw a parallel, consider likening a computer program to a theatrical performance. Virtually all theater performances comprise a composed script, which actors diligently study and commit to memory for vocal delivery to an audience. However, the script is not the sole element at play. The performance encompasses a broader spectrum. Directors make determinations about lighting, costumes, and stage design. This holistic performance entails numerous design choices, including set arrangement, lighting effects, and costuming. This creative process mirrors the journey of programming in Python, where intricate design decisions play a pivotal role. In Python, scripting bears similarity to crafting the specific dialogues for actors. In the realm of Python, commencing with a comment is advisable. Comments serve as annotations programmers attach to elucidate the purpose of their code. Let's insert one at this juncture. We initiate comments using the hash symbol to signal their presence, followed by details clarifying our intent. In this instance, our objective is to exhibit Hello Python on the screen. Now, let's inscribe our debut Python code line. This code snippet employs the print function. Print dispatches a designated element to the screen. Following print, we enclose our intended output within parentheses. Here, we seek to showcase the string Hello Python. It's imperative to enclose string data within quotation marks. These quotation marks constitute just one facet of the syntax you'll come across in Python. Syntax governs the principles that dictate appropriately structured constructs within a programming language. Without further ado, let's execute this code, permitting the computer to display the string. Congratulations, you've successfully executed your maiden code line. As our syntax adheres to correctness, the string is now unveiled. With this exposure to scripting and executing code in Python, we are poised to delve into its fundamental constituents.
Jupyter, we have three different types of cells: code, markdown, and raw. Code is the one that we write a command and execute it. Markdown is the one that basically we use it in order to format the text, highlighting, make it headings, bold, make a hyperlink, and so on. So let's say, for instance, we're going to change it to markdown, and I'm going to paste text over here. Now, as you see that we have introduction. If we pound sign before introduction and a space, it makes it as a heading. And we can repeat this, we can copy and paste this over here, and to see that if we keep adding more pound sign before that, is going to make it different size. If we double click on this and we go back in order to make it changes, now we can come in here. Let's say we want to make this program in this word or another word italicize or bold or make a hyperlink. So if we put a star before and after programming, it's going to make it italicized. And if we put a double star before and after language, it's going to make it bold. Let's run it, and we're going to say programming has been changed, and also language is being bold too. So now let's say we want to make Python a hyperlink to Python website. So we're going to put a bracket before and after that, and open and close parentheses and the address of the Python. And if we run this, and we see that the Python is being linkable, so we can click on it and take us to the Python website. And the last type of the cells we are going to talk about, raw cells. Raw cells are unformatted text. They do not interpret any kind of markup language or formatting syntax, and they display exactly as is being placed in it. So let's say if we are pasting text over here and we change shaping of and the structure of that, and we make it as a run, it exactly stays the way it was, and it doesn't have any effect on the rendering and execution or any kind of modification on the output of our program. So from now we are going to start using code cells. In Python programming, if we need to write a comment, anything that helps us to remember why we put this line of the code, we're using a pound sign, and then we can put this is a comment, and this text over here is not going to have any effect in our program. So many times that you're writing a code, you may gonna forget, why did I put this for loop or this statement or this at this part of the program. Then by placing a comment using a hashtag or pound sign is going to make that line the comment.
For beginners learning coding in Python, it's best to start with a clear understanding of fundamental concepts like variables, data types, loops, conditional statements, and functions. Begin by writing simple programs and gradually move on to more complex challenges. Working on small projects that interest you can provide practical experience and motivation. Regular practice, reading code written by others, and seeking help from online communities when needed will foster a strong foundation in Python programming.
Now we're going to write our first line of the code, which is going to be print hello world. So print is a statement that displays anything is inside the parentheses. If it's in a string like this, which is between the quotation mark, it's going to print exactly like that. And if it's an integer, either it's going to print the number or the result of that statement. So let's print this one. We're going to click on this triangle, run the program, and this is going to be our first result outside of the printing statement. And now we're going to add another line of the code, which is going to be 1, and we're going to hit run, and we're going to see the second output, which is 1, is outside. Now we can run another statement, print 1 times 10, and execute this program, and the result is 10. Or we can type print and then open parentheses. Now we can put something like letter A inside the quotation, and then using a times 10. And this, by executing this code, we see that the output is 10 times printing the letter A.
In Python, data refers to the information or values that a program processes and manipulates. This can encompass various forms, such as text, numbers, and collections like lists and dictionaries. Data serves as the foundation for performing calculations, making decisions, and creating meaningful output. In Python, data types define the nature of values that variables can hold. They categorize data into different classes, each with specific characteristics and operations. Common data types include integers, floats, strings, booleans, lists, tuples, dictionaries, and more. These data types determine how values are stored in memory, how they can be manipulated, and the operations that can be performed on them.
So now we are talking about data types. A data type is a category for a particular type of data item. Python uses several data types, including strings, float, integers, boolean, and list data. When we printed hello world, basically that was an example of a string. String data is a data consisting of an ordered sequence of characters. These characters could be letters, symbols, spaces, and even numbers. Numbers in the string data cannot be used for calculation. All characters in the string must be placed inside the quotation mark. So here are some examples of data strings. Data strings must be inside a quotation, and anything between these two quotation marks is going to consider it as a string. Even this number 20% that's inside the quotation is still considered as a string. 5.0 inside the quotation mark is going to consider it as. So now we're going to try one of these lines, and as you see, we're going to print update needed, and we're going to run. So the result is the same as exactly what was between the quotation marks. Also, we're going to try to print the others. So let's say print 35, print 3.5, and print 20%. And if you hit the run, we see the result is 35, 3.5, and 20%. And these are still going to consider it as a string.
Before we dive into creating meaningful examples with code, let's start by understanding a crucial concept: variables in Python. Think of a variable as a labeled container that can hold different types of information, like numbers, text, or even complex data structures. Instead of dealing directly with data values, we use variables to give these values a name that makes sense to us. Just like labeling folders to organize files, we label variables to organize and manage data in our programs. When we create a variable, We're essentially reserving a memory space to store a value. For instance, if we're making a program to calculate someone's age, we can use a variable called age to hold that value. To create a variable, we use a name that follows certain rules, like starting with a letter or underscore. Then use the equals symbol to assign a value to it. The value can be a number, text, or any other data type. As our program runs, we can change the value stored in the variable, updating it to reflect new information. This flexibility makes variables a powerful tool in programming, allowing us to create dynamic and interactive applications. In Python, the string data type represents sequences of characters enclosed in single or double quotes. Strings are used to store and manipulate text-based data, such as words, sentences, and symbols. They can be used for various purposes, including displaying output, receiving input, working with textual data, formatting messages, and much more. Strings support a wide range of operations like concatenation, slicing, searching, replacing, and formatting, making them essential for handling textual information and programming tasks.
String data is a data consisting of an ordered sequence of characters. These characters could be letters, symbols, spaces, and even numbers. Numbers in the string data cannot be used for calculation. All characters in the string must be placed inside the quotation mark. So here are some examples of data strings. Data strings must be inside a quotation, and anything between these two quotation marks is going to consider it as a string. Even this number 20% that's inside the quotation is still considered as a string. 5.0 inside the quotation mark is going to consider it as string. So now we're going to try one of these lines, and as you see, we're going to print update needed, and we're going to run. So the result is the same as exactly what was between the quotation marks. Also, we're going to try to print the others. So let's say print 35, print 3.5, and print 20%. And if you hit the run, we see the result is 35, 3.5, and 20%. And these are still going to consider it as a string. In Python, strings are sequence of characters, and each character in a string has a position, or called index. We have two different types of indexing: positive indexing or negative indexing. The positive index starts from the very first character, and it's going to start from 0 all the way to the end. So 0, 1, 2, 3, 4, and 5. And in negative indexing, it starts from the end of the string, and it's going to be -1, -2, -3, -4, and so on. Both positive or negative indexing are commonly used to access individual characters, extract like substrings, or manipulating data. In this example, we have Alice has been assigned to first name, Smith has been assigned to the variable last name. So this code combines the first name and last name with the space between them, and is going to print it. So as you see, we have Alice, Smith, two separate variables became one string together, concatenated together. Let's say we have a registration system and we want to combine the first name and last name and display the full name on the screen. So that can be used for that reason. In this code, we have the string hello, comma world assigned to the variable text, and len function calculates and stores the length of the variable text and stores the value into the length variable, and here we're going to print it. So as you see, we have 13 characters in this string. So if you count it, it's going to be 13. We also have uppercase and lowercase functions. For instance, we have a string Python programming is being assigned to the variable message, and we're using upper message, which is this one, dot upper. So upper is going to manipulate this text, is going to manipulate this string, and it's going to change it to uppercase, and it stores the result into uppercase message. And the lowercase is going to convert the whole string into lowercase and store it here in the lowercase message variable. And now we printed both of them over here. So as you see, the uppercase the whole entire string changed to uppercase, and in this case the whole entire string changed to lowercase. Now we have another function called slice. So slicing extracts a position of a string. Let's say over here we have the string coding is fun, and it's being saved into variable sentence. So what this line of code it says start from the character 7 and up to the 10, but 10 is not counted, only up to the 10. So let's try it. So we have 0, 1, 2, 3, 4, 5, 6, and 7. So this is character 7, 8, 9, and 10 is not counted. So from character 7 to 10, basically 7, 8, and 9 is going to get sliced, is going to get separated. This part of the string is going to get saved into the variable substring, and we're printing it. So as you see, we have I, S, and white space that is not showing, but if we highlight it, you're going to see we have 3. We can also change this 7 to 10, try another way, from 2 to 5, and then let's run it again. So we have DIN, so let's count it. 0, 1, 2, so starting from 2, 3, 4, but not 5, so 2, 3, and 4, and the result is the same thing, DIN. One of the use case of this slicing can be used when like extracting the domain name from an email address. Our next example is going to be replacing the string. We have this sentence, which is a string assigned to the variable code, and with using replace, so we're saying code this variable, replace it. Anytime that you see word change, replace it with difference and save it into new code and then print it. So let's try it. As you see, we have change is being replaced by difference. We can also add another part to it, so you can say change now, and let's run this code again. And as you see, we use the word change twice in this sentence, and both of them is replaced with difference.
Lists in Python are ordered collections of elements, which can be of any data type. They are defined using square brackets and can store multiple values. allowing for easy manipulation, addition, and removal of elements within the list. Lists are one of the fundamental data structures in Python and are commonly used to group and work with related data.
Now, before we go to the next example, I'm going to explain you another type of data in Python, which called list. So list data is a data structure that consists of collection of data in a sequential form. As you see, we have this collection is 12, 36, 54. This is all different elements of a string. This one are boolean, and this is like a mix of data. And always it starts with open bracket and close bracket, and it always is comma separated. Now we're gonna another line of code here. In this example, we have this string, which is a sentence, and it's been assigned to a variable called sentence. And we're using a split function, splits this sentence and store it as a list data that we just talked about it. It's stored in the variable called words, and in the next line we are printing words. Let's run this. So the split function splitted this string into words and saved it as a list. So as we see, Python is the first element and so on all the way to the end. Our next example is going to be string formatting. So we have John has been assigned to variable name, 30 assigned to age, and we use format function to insert the value of name and age in this string. So anytime that it gets to these curly brackets, it's gonna replace by the order, is gonna replace the variable into these brackets, and it's gonna print it over here. So let's run it. We have my name is John, so the name, the value of variable name, which is John, is been replaced here, and also the value of variable age is been replaced over here. And we may gonna use this type of changes for personalizing messages or email with dynamic content. Our next example is gonna call it stripping a string. As you see, we have a string that it says it starts with few leading white spaces and trailing white spaces both sides of this string. And with the strip function, we can remove these white spaces and save it in the new variable called stripped text. And in this line, we're going to print. So as you see, this printed text doesn't have the leading or trailing white spaces. If we add another line, so as you know, Python is compiling the program line by line from the top to the bottom. So over here, we added this line. Basically, it prints the original text, and then we printing the stripped text. Let's run this. As you see, the original text has leading white spaces, which we cannot see, but when we highlight it, we can see it. It has leading white spaces, and also at the end of it, but the strip one doesn't have it. Our next example is joining the strips. So we have this list data type, coding, is, fun, and is being assigned to the variable words. We can use join function in order to join these words together, but leaving one white space between the words. So it's going to join these words together, save it in the sentence, and we are printing the sentence. The result of joining this list is a sentence that we have it over here.
In Python, a float is a data type used to represent real numbers with a decimal point. Floats can represent both whole numbers and fractions, making them suitable for a wide range of numerical calculations. They are a fundamental data type for handling non-integer values in Python.
So our next set of data is going to be float. Float data is consisting a number with a decimal point. And here are some examples of floating numbers. So as you see here, minus 2.2, minus 1.34, 0.0, and 0.34 are floating numbers. And we're going to run some codes with floating numbers. The first line of the code that we're going to do is just going to be basic arithmetic codes. So this is going to be arithmetic, and then we're going to choose two values. We're going to choose x 3.5 and y is equal 1.5. And let's say we're going to run a print statement when we're going to say x plus y, and we're going to run this one. So the result value, it came 5. Now we're going to print another statement, and this time it's going to say x minus y, and so the value is equal to. Now, and we can do it with, of course, other multiplication or division as well. And now let's say we're going to create another variable, sum going to call it sum of x, y, and then we're going to assign x plus y, and then of course we're going to print sum of x, y. So let's print this one. Here is another example. So we're going to have two values of num1 equals 3.14 and num2 equals 2.71, and we're going to add these two numbers and we're going to store it into the sum result, and we're going to print. As you see, the output result is 5.85. We're going to run another example, which is going to be, we have a numerator 10.0, we have denominator 2.5, and also we're going to divide these two values and we're going to store it in a variable called quotient, and we're going to print it. So let's run it, see the result. So 10.0 divided by 2.5, it came 4.0, and still the value stays as a floating value. We also can try another example, which is going to be, we have a variable called base equal 2.0, and exponent is going to be 3.0, and we're going to do base, and these two asterisks is going to be basically to the power. Result is going to be the value of base to the power of exponent, and it's going to print the result, and we're going to run this code, and the value is going to be 8.0. In this example, we are going to convert the temperature from Fahrenheit to Celsius using this formula. So basically, the first variable is going to be Fahrenheit 98.6, with the calculation Fahrenheit variable minus 32 times 5/9 stored in the Celsius variable, and now we're printing Celsius. So as you see, equals 37. Another example that we can try for floating number is going to convert the US dollars to euros. So let's say the variable US dollars equals 500 and the exchange rate equals to 0.85, and this calculation is going to store the value of the conversion into the euros, and we're going to print euro. So we're going to say $500 at the exchange rate of 0.85 is going to be 425 euros. So in cybersecurity, monitoring this space is crucial for preventing denial of service attack or identifying the potential storage issues. Total disk space equals 100, let's say, terabyte, and the usage is 30.5, and we're going to calculate the free space, which is total disk space minus used space, and printing the value at the end. So we have 69.5 terabytes has left. In cybersecurity, random numbers are often used for generating encryption key or creating unpredictable values for security protocols. Let's say running this example, we have a total space, I should explain import first, and then we're gonna run this code. So in this example, we are going to use import as well. So addition to the floating numbers, we are going to use import. Import is basically bringing functionality from external modules or libraries into current Python scripts. It has functions, classes, and variables that help us in order to run our programs without going through those coding expertise. In cybersecurity, random numbers are often used for generating encryption keys or creating unpredictable values for security protocols. Let's say we have this set of code. The random library is going to call random function and creating a value, and is going to store it into random float. And we are planning to print this random float number. By executing this code, we have this value, which is very useful in cybersecurity. This code generates a random float number between 0 and 1. In cybersecurity, understanding the data loss percentage can help quantify the impact of security breach or incident on sensitive information. We're going to run a code that calculates the percentage of data loss. Let's look at this example. So our first variable is called initial date equal 1000.0, and lost data equals 75.5, and with this calculation, parentheses, lost data divided by initial data times 100, and that's going to be stored in data loss percentage. And now we're going to print the data loss percentage, and let's look at it. What's going to be 7.55.
Integers in Python are a data type used to represent whole numbers, both positive and negative, without any decimal point. They can be used for arithmetic operations and come in various sizes, depending on the platform and the Python version being used.
So now we are focusing on integers. Integers are a type of data that consisting of a number that does not include a decimal point. Let's look at these numbers. Minus 100, minus 12, minus 1, 0, 1, 20, 500. These are the numbers that do not have decimal points, and they're considered as integers. Now we are going to practice examples for integers. In this example, we have the variable x is equal 5, y equals 3, and addition of the x plus y is going to get saved into the sum underscore result, and the printf statement is going to print the value stored in sum results, and he's going to hit the run. And as you see, we have 8, and the value is integer. Next code that we're going to try, we have the variable a equals 10, variable b equals 4, and the difference of the a minus b is going to be assigned in the variable difference, and the printf statement is going to print the value stored in the difference. We're running the code. The value is 6. Here is another example. This time we're doing multiplication. This code multiplies two integers num1 and num2, which is 1 equals 7 and num2 equals 2, and stores the product in a variable called product, and the printf statement is going to print the result 14. So 7 times 2 equals 14, and 14 is the value is being stored in product. Our next example is going to be, we have two variables, one numerator, and the value 15 has been assigned to it, and also a denominator, which the value of 3 is being assigned to it. This code divides the numerator by the denominator is going to get saved into the quotient, which is here, and the printf statement is going to print the result. So we have 5.0. As you see here, the result value of the two integers, it became a float. So 5.0 is the product and basically the final result of division of two integers. This code calculates the absolute value of number. So the value minus 9 is been assigned to the variable number using the ABS, which is the absolute function, is going to return the absolute value of number, and it stores it in a variable called absolute, and then print statement is going to print the value, which is 9. Our next example is going to be converting to integers. As you see in this example, we have a variable called text underscore num. The string of 42, which is not an integer, is a string. So double quote both sides of 42, it makes it a string. So the variable text num is a string. Now we are using a function int This function converts the string 42 to an integer using int function, and it stores to a variable called integer underscore num. So, and we print it. So as we print it, the value is 42, and this is not a string, this is an integer now. So by using int function, we converted the string into integer. Let's look at some examples and find out what is the usage of these type of code in cybersecurity, how we can use it. We have this code. This code calculates the remainder of the num. So we have a variable called num, and also we have a variable called divisor. And over here, this percent operator is returning the remainder of division of num by divisor. In cybersecurity, modules can be used to determine whether a given number is evenly divisible, which can be helpful in tasks like checking patterns in the data. Our next example is going to be modules. In cybersecurity, modules can be used to determine whether a given number is evenly divisible, and which is useful to tasks in this code. We have variable called num, and the value is 17, and divisor is equal 5. And this code calculates the remainder of num when it's divided by divisor. In cybersecurity, this can be used to determine whether a given number is evenly divisible, which is good when we are checking for pattern in the data. So let's run this code, and the result is 2. So the remainder of dividing 17 by 5, the remainder is going to be 2.
In Python, a Boolean data type represents two values, true and false. Booleans are used to evaluate conditions and make decisions in code. They are essential for control flow, such as in conditional statements if-else, loops, and logical operations.
So in our next example, we are doing comparison. We have value 1, 15, and value 2 is 10. This code compares whether value 1 is greater than value 2, and it prints the result. Let's get it. True. So it is. So it is value 1, which is 15, greater than the value 2. In cybersecurity, comparisons are crucial for evaluating conditions. For instance, if your maximum time of attempts in order to log in to a system is been 3 and someone did 5, by this type of comparison you can block the access, which is very helpful. So in our next example, we are doing comparison, but this time we're going to do less than. So in this example, we have variable num1 equals 25, variable num2 equals 30, and is going to compare these two values if num1 is less than num2. In that case, whatever is the result is been stored in a variable called isLess, and the print statement is going to print the result, and we see true. So in cybersecurity, this could be corresponded to evaluating if a system resource usage below a certain threshold. Our example for integers are going to be something like comparison if they are equal to, and so in this example we have variable called num_a equals 50, num_b equals 50, and the comparison result of these two variables is going to be stored in is equal, and the print statement is going to print the result. So we try it and it's true. So in cybersecurity, equality checks can be used to validate the user inputs. Our next example is going to be logical operator. So we are going to try a logical operator of AND. We have value x equals 5 and the variable y and the variable value y equals 10. This code uses the logical AND operator, so this is an AND operator, to check if both values of value x and value y are positive, and it stores the result in both positive, and the print statement is going to print it. So let's try it. So true, we have value x is greater than 0. Value x was 5, of course, is greater than 0. And value y was 10. It is greater than 0. Since both sides of the operator are positive, the return value to both positive is true. So logical operators are very useful tools in programming. In cybersecurity, logical operators are vital for creating complex conditions, such as evaluating multiple security conditions before granting access. A variable is a symbolic name that represents a value. It's used to store and manage data that can be used later in the program. Let's say we are planning to calculate the area of a rectangle. So let's say we have a variable called length, and we store the value of 10 in length. And also we have a variable called width, and we store the value of 5 in it. And with this calculation, length times width, a rectangle, multiply together, and the result is going to get saved into the variable of area. Now in this line we use the print statement. The f string allows you to insert the value of area into this line and also print it. So let's run this program. As you see, the area of the rectangle, which is exactly this part that we place it inside the f string in print function. So we have a print function, f double quotation opening and double quotation at the end, and this string in the middle. So we have the area of rectangle is, and then we have this variable that we assign the value of it. We place it inside a curly bracket, and when we print it, it's going to place the result of this multiplication, which was stored in area, printed as an output. Now we are trying to write another code and execute it. In this program, the input function prompts the user to enter their name. The input stores the entry into the variable username. And in the next line, as we see, the variable username is being concatenating, means is being inserted or is being combined and linked to this message. So we have hello plus username, which was the variable that we took it as an entry from the user, and then the rest of the message, which is going to be welcome to the world of coding. And finally, on the last line, the print function is going to print anything that has been inserted into this string, which is a welcome message. So let's run this program. So here is the entry. It says enter your name, and I'm going to say CySyst and hit enter. So it says hello CySyst, welcome to the world of coding.
That's the end of part 1. And the link to the next part will be available right here on the screen shortly. Feel free to click on it to continue learning. Wrapping up the video, once again, I'm your host, CySyst. Thanks a million for tuning in. Please don't forget to give it a thumbs up, hit that subscribe button, and ring the notification bell. See you next time. By the way, be sure to check out our other informative videos. There's a whole treasure trove of knowledge waiting for you. Just click over to our channel and dive in. If there's a specific subject you're curious about, let us know in the comments. We're here to help and create content that matters to you. Happy learning!